Welcome to the next tutorial on electric current. In this tutorial, I will start explaining the solution to the problems, starting from the problem number 1, which states that a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm. You have to find out how much current would flow through the 12 ohm resistor. As a hint, I asked you to draw a diagram. So let me start by drawing a diagram. Okay. The battery is 9 volt. I know my drawing is not so good, and in this drawing board it is even worse. Okay, let me see if I can draw it little bit better. This is the 9 volt battery. I hope it is little better now, but it's not so good. Okay, it is definitely not a good diagram, but somehow I think it will help you to understand the concept. Okay, so the resistances are 0.2 ohm first resistance, second is 0.3 ohm, third one is 0.4 ohm, then 0.5 ohm, and finally a 12 ohm resistance. Okay, the battery is 9 volt and the resistances are 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 and 12 ohm. You have to calculate what is the amount of current that flows through the 12 ohm resistor. Now remember, this is a series connection, so same amount of current will flow through all the resistors, even 12 ohm. So if we can calculate the what is the current flow, we will get the answer. So how to solve this problem? First of all, there are multiple batteries in series, so let us first calculate what is the net resistance. So we have to first calculate the net resistance. If we have the net resistance, then using Ohm's law we should be able to calculate the current flow. So what is the net resistance? Let it be R. That means let the net resistance be R. Since it is in series, so R will be algebraic sum or sum of all the individual or all the component resistances. So let us calculate the net resistance R and let the current flow be I. So we have to find out the value of I, because if we can calculate I, that same I will be the current through all the resistances. And first, to do that, first we have to calculate the net resistance. If the net resistance is R, then we can easily calculate R by summing up or by adding all the individual resistances. That means R equal to sum of all the resistances, 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12, which comes to 13.4 ohm. You can do the calculation, it is 13.4 ohm. So the net resistance is 13.4 ohm. Okay, and voltage is 9 volt. Okay, then what is the current flow? Now we can use Ohm's law here. let me change the color a little bit. Let the current flow I equal to V by R, that is according to Ohm's law, because V equal to I into R, therefore I equal to V upon R. Now V is 9, R is 13.4. So if we divide 9 by 13.4, we will get the value of I, which is the current flowing through the resistances, or through current flowing through the circuit. So 9 upon 13.4 is coming as 0.67 ampere. Therefore, the current flowing through the circuit or through the resistances, or we have to mention here through 12 ohm resistance, is 0.67 ampere. So remember, this same current is flowing through all the resistances, whether it is 12 ohm or it is 0.2 ohm or whatever it is.